and Society. And I am delighted to have a new friend and colleague that we met in the summer in Helsinki to join us today, Dr. Laura Getz, who is from University of San Diego. She's a professor of neuroscience, cognition and behavior, and program director for cognitive neuroscience, cognition and behavior. Dr. Getz joined the faculty at University of San Diego in fall 2019, following a 3-year postdoctoral fellowship at Villanova University. Her research takes an interdisciplinary approach to understanding auditory perception, with research encompassing speech, cross-modal, and music perception using a combination of behavioral, cognitive neuroscience, and computational modeling as approaches. In her work, she seeks to determine to what extent cognitive processes are encapsulated from one another and how perception is influenced by individual cross-cultural differences, previous knowledge, expertise, and task demand. So with that, let's welcome Dr. Getz, and we'll have time for question and answer at the end.
Hello, everyone. You can hear me up there in the back, okay? Okay, so thank you very much to us all. I think it's funny that I'm so close down in San Diego, but we had to go to Helsinki to meet each other last summer. So excited to be here and share some of my current research projects with you today. So as you said, I'm at the University of San Diego and in the newly formed this year Department of Neuroscience, Cognition and Behavior. We just broke off from psychology, so we are now our own separate department, and I run the Language and Music Perception Lab. And I just wanted to thank all of my undergrads. We only are an undergraduate institution, so all of my work is in collaboration with these very enthusiastic group of undergrads who helped make my research program happen. So generally, I'm interested in the role of interactions in understanding auditory perception. So although perception is often studied one modality at a time, in my work, I aim to show the importance of interactions between sensory information received in the auditory and visual modalities, and also as well as how higher order information interacts with this sensory information, so cognitive processes such as prior knowledge influencing our auditory perception. So in other work, I've shown the importance of interactions in speech perception as well, looking at audiovisual interactions with the McGurk effect and top-down influences using EEG methods. But today, I'm going to be focusing on the music side of my research with 3 experimental examples. The first one will relate to perception, specifically of complex rhythm perception, syncopation perception. The second will be related to how attention relates to the interaction between musical elements and their perception of advertised products. And the third will look at how context affects the relationship between how melodies might be able to be used as a memory aid. So starting with syncopation perception, this was work that I started at my PhD at the University of Virginia. So there are 2 ways that you can gain expertise. So informal expertise could be gained through informal engagement in everyday musical activities, and it's been shown that members of a culture have the ability to recognize most of the structural elements of music in their particular culture without formal training. Whereas formal music expertise is gained through periods of performance training, either on an instrument or a voice. And there are specific things like frequency or pitch discrimination or duration discrimination that show advantages with formal training. And there's some evidence that this performance is related to the instrument that that's being played. So string players might be better at pitch discrimination, whereas percussionists might be better at duration discrimination. Right? So the question that we asked in this line of research was whether all musicians have an advantage on tasks over non-musicians if it's a music-related task, or if there are specific types of musicians who have some sort of advantage. And we did this specifically by asking about genres. So we asked whether genres matter in determining rhythmic expertise. You have to have a specific type of rhythm training to be considered an expert at this particular type of task. And because there are many forms of rhythmic expertise, my collaborators and I chose a test case, which was a form of Latin American music called salsa music. And we chose this because it offers a convenient way to operationalize rhythmic expertise, because each style of salsa music has a characteristic rhythmic underpinning called a clave pattern played by an instrument called the claves. I'll just play a brief example. So this has a bass drum beat and then the clave played along with it. Right, so musicians say that playing the wrong clave pattern with a given dance style will destroy the integrity of the piece. One specific quote, to quote, "The clave's importance to salsa music cannot be overstated. It's truly the basis for everything that happens musically in the band. All of the musicians relate their parts to a clave rhythm, whether it is obvious or not. Every salsa tune has a designated clave rhythm that must be adhered to at all times." All right, so our question was whether this is a musician saying this and they know that because they have music training, whether it's a function of musical expertise, or whether the clave's importance really is implicit in the music and even naive listeners would be able to pick out the correct clave pattern. Right, so we used two different clave patterns here. So the 3-2 and the 2-3 song clave pattern, which are used in different types of Latin music, bamba and merengue versus calypso and mamba. And if you read music, or even if you don't, you'll notice that it's called 3 because there are 3 notes in the first bar and 2 in the second. Then the other one, it just flips those 2 measures, so it's 2 and then 3. Right? And these have a syncopated pattern, meaning not all of the notes fall exactly on a beat. So the 3-2 is the one I just played for you. The 2-3 sounds like this. Right, so these are actually used in salsa tunes. So we wanted to take these two and we created 3 alternative versions that are not used in salsa music. So we created unsyncopated versions of the 3-2 and the 2-3. So all we did was take the second note of that first measure and move it on to beat 3 instead of off the beat. So now everything falls on a beat like this. Right, not nearly quite as groovy, right? Everything's now falling on the beat. And then we also created this control pattern, which we made as regular as possible. It still has 5 notes, but everything is falling on these dominant beats. Right, so we then took these 3 versions that we created in addition to the 2 real ones, and we put them in a variety of music excerpts. And we had people listen to all 5 versions and choose which one they thought was the real version of the clave pattern that should go with that music that they were listening to. So I'm not going to give you all 5 options, but I'll just play the control pattern and then the correct pattern here in an example of bamba music. Oops. Right, compared to this. So on each one of these trials, people had to listen to all 5 versions. After they had listened to all 5 versions, they clicked on the one they thought was the correct one, then they clicked choose. If they got it wrong, we made them keep going until they got it right on each trial. So that forced hopefully more close attention, and we could see if they got better over the course of the 12 trials and picking out which one was the correct one. Right, so in our first study, we did this with a variety of different participants. So we first divided people based on their self-reported familiarity with salsa music and the clave patterns specifically. So you can see I've divided people if they reported less than 50% versus more than 50% familiarity with the clave patterns and salsa music. For the purposes here, I'm just going to combine all of the people with low familiarity together in the results, but we did have people, we divided them by their years of music training and also their salsa dancing experience. Then for the high familiar people, we combined the non-musicians and dancers together into a novices category just because we didn't have enough people to separate those out. And we compared them to musicians who specifically had formal salsa training, so they had experience with salsa music previously. All right, so in the results I'm going to show you 3 different outcomes of how they could respond to this task. They could choose one of the 3 manipulated patterns, which are never used in salsa music, right? Which would show they're just sort of picking anything. They could choose the opposite syncopated pattern, which would show they know that syncopation is important, but don't just choose between the 3-2 and the 2-3 correctly. Or they could actually choose the correct pattern. All right, so you can see the 3 groups here across the bottom, the low familiar, the novices, and then the musicians. And this is going to be the percentage of times that they chose each one of these responses. So you can see that the people with low familiarity, they pretty much just click any of the 5. They don't know. So they are just clicking one of the 5, whereas the novices who have high familiarity, they know that syncopation is important, right? So they're only choosing between the 2 syncopated patterns, even though they might not get the right one every time. And it's only the musicians who are highly familiar with salsa music who actually choose the correct pattern more than we would expect. So this is initial answer that it does seem like genre expertise matters. And so our next question then was, can you become a rhythm expert after just 1 semester of training in this type of music? So at the University of Virginia, there's this class called Learn to Groove, and it's taught by this expert percussionist. They learn a variety of African and Latin drum patterns. They're tested on their performance abilities and their improvement throughout the semester. So we had participants do our task at the beginning of the semester and then again at the end of the semester after they had taken this class. And we compared it to people from our intro psychology pool who just did it at the beginning and end of the semester with nothing else happening in between. All right, so I'm going to show you with the same type of responses they could have made, except you're just going to see this broken up into all 3 different options instead of combining them together. All right, so this is our control. This is our people who just did the task at the beginning and end of semester. And you can see that, again, they're just sort of, they're picking anything. They don't get better at the end of the semester because nothing has happened in the meantime. The people in the class already are slightly choosing the syncopated patterns more at the beginning of the semester, but that might be some self-selection effect of they were already interested in this type of music when they decided to take the class. But they do improve from the beginning to end of semester, barely ever choosing those manipulated alternatives at the end of the semester and choosing the correct pattern more than would be expected by chance. Right, so this shows that formal training over a course of a semester can increase your ability to do this type of rhythm perception task. So the last question we wanted to ask then was whether informal exposure from everyday listening can also impact your ability to detect the salsa clave pairings. And because there aren't a lot of people who have listened to a lot of salsa music growing up in Central Virginia, we collaborated with Lynn Perry from the University of Miami to collect data from participants who had grown up listening to salsa music. So they have a lot of informal exposure, even if they don't have formal training in this type of music. And so you might predict that they would look similar to people, musicians, even if they don't have the technical language, right? They've still had a lot of exposure to it. Or it could be that because they don't have that formal knowledge, they could look more like the people with low familiarity. So this is the participants from Virginia from experiment 1, broken up just into people with low versus high familiarity. And so we can compare the native listeners then, the people who've grown up listening to these 2 groups. And it turns out that they look more like the people with low familiarity than the people with high familiarity. Right? So the idea here is that the informal exposure gained from everyday listening is not enough to aid them in choosing the correct pattern. So what this tells us in terms of genres mattering is that informal experience might help you, right? You might get slightly better with informal experience compared to no experience at all, but it's not sufficient in being able to do this type of task. Whereas only formal training in the genre, you need that formal training to be able to do this type of complex rhythm perception pairing task, right? Which shows that your prior knowledge in this case about genres is actually influencing how you perceive and interpret music, right? So your prior exposure is changing how you're perceiving these basic auditory patterns. Okay, so that was an example related to perception. I want to move on from perception to talking about the correspondence between auditory and visual modalities and how attention can impact that relationship. So in this example, our question was whether different musical features, different musical elements like the pitch or the tempo or the timbre can actually change someone's perception of a product being advertised in a radio advertisement. And this was work done in collaboration with Jordan Tran, who was an undergrad who graduated a few years ago from USD. So before I get into the specifics of this project related to music, I want to give you a little bit of background about how we got to this particular question. So for my dissertation work, I looked at how the perception of pitch, high versus low pitch, is related to a variety of visual dimensions. So for example, in past research, people have shown that you're generally faster to pair a high pitch with a small circle and a low pitch with a large circle. The same thing with something high on the screen versus low on the screen, something with high versus low spatial frequency, something that's bright compared to dark, and something that's more sharp compared to something that's more rounded. All right, so what I did for my dissertation is instead of just having people pair it in this direction to see the advantage, I forced them to pair it in the opposite direction, right? So I made a task where they had to pair a low pitch with a small circle or a low pitch with something that's high on the screen or high spatial frequency or bright or angular, as opposed to the direction that people say is more natural. Right, so this allows us to look at whether when I force you to pair it the opposite direction, whether you can do that with equal reaction time because now the task is demanding you to do it in the opposite way, or whether it's still really hard to do it even though I'm telling you to do it in the opposite direction. All right, so what we found is that for pitch and size, for example, you can do it just as easily. You don't really care if a high pitch is paired with a large circle or a small circle. But if a high pitch is paired with something that's low on the screen, that's really, really hard for you to make that response, right? And then the other one sort of fell on a continuum in between. And we found that this sort of makes sense if you think about the metaphor that we use for pitch in English. At least the dominant metaphor is height, right? We talk about high versus low pitches. We don't talk about large versus small pitches. And so it seems like it depends on this sort of like the task demands and your knowledge of the task. And so further, in a more recent study, I put these correspondences in competition with each other. So that means that we have the traditional congruency advantage here, but then I created trials where height was congruent, but size was incongruent. So you'd have a high pitch paired with a circle that's high on the screen, but it would be a large circle as opposed to a small circle, right? And then when size was congruent, you'd have a high pitch paired with a small circle, but now it's low on the screen, right? So one of them is congruent, the other one is incongruent. And we found that it only really matters if pitch and height are congruent. Again, size doesn't really matter. You can pair whatever size object you want, but if you're trying to pair a high pitch with something that's low on the screen, that's going to be really hard for you to do. And so what we found from this cross-modal, these basic correspondences, is that it doesn't seem like all of these are automatic. That there are top-down influences based on the demands of the task, the specific instructions that I give you, and also the language and the metaphor that you use for pitch. right? And so at least in English, we found superiority for the pitch height correspondence, because that's the metaphor that we use to describe pitch. Right? So this is interesting. The main problem with this is that we've got like sine tones and a bunch of circles appearing on the screen, which is not very much what we are used to seeing in everyday life. And so to try and look at more ecological stimuli, we started looking at pitch of the voice and pitch in music instead of just looking at these sine tone pitch relationships. So as part of this recent replication project, which is currently under review, where we were looking at 174 claims across a bunch of different journals across social and behavioral sciences. And the specific claim that I was helping to replicate as part of this larger project was this task by Lowe and Halls, which I did in collaboration with Erin Hannon from University of Nevada, Las Vegas. And in this original study, they found that the same radio advertisement, if the voice in the advertisement was lower, people would rate the advertised sandwich as larger. And if the voice was higher in pitch, they'd rate the sandwich as smaller, right? But we replicated this with 615 people and did not find it to replicate, that we did not find a difference between the pitch of the voice changing your perception of the advertised product. Right? So what we wanted to do next, what Jourdain did for her project, was we looked at a variety of musical features instead of just the pitch of the voice. So now the pitch of the voice is exactly the same across the two versions of the advertisement, but we changed background music accompanying the advertisement to either be higher or lower in pitch. So the same song, but higher versus lower in pitch. We had the same song, but faster or slower in tempo. And then the same song, but played in a trombone timbre versus a flute timbre. Right? We created 3 different advertisements here. We replicated the one with the sandwich being larger, seeing if the sandwich was larger or smaller with a different pitch. We created one for sneakers that we created called the Zoom Ride 3000 sneakers. And in the background music was either faster or slower in tempo. And then we had a 2-in-1 laptop that we had the background music was the same song, but again, trombone or flute timbre. We wanted to see whether that would affect the durability of the laptop that we were advertising. So I'll just give you an example of what these sounded like.
Looking for some top-notch shoes? You're in luck, because Cosmos has just the pair for you. Going on a run? To the store? The office? The studio? Come on, Cosmos shoes can do it all. Sleek, stylish, comfortable, and available in a variety of colors and sizes.
Right, so and then the ad is the same, but the music is going to be slower.
Looking for some top-notch shoes? You're in luck, because Cosmos has just the pair for you. Going on a run? To the store? The office? The studio? Come on, Cosmos.
Right, and then for the timbre, we had the same song.
It's time to work. It's time to focus. Time to connect. Want something fast? A touch screen? The latest graphics technology? Go beyond traditional laptops and think in color with the brand new Cosmos 2-in-1 laptop.
Compared to flute.
It's time to work. It's time to focus. Time to connect. Want something fast? A touch screen? The latest graphics technology?
All right, and special shout out to my husband here who recorded all of the advertisements. He does voiceover work, and so he's like the official voice of the Lamp Lab. I make him record all my stimuli for me. So in this first study, what we did was we just had participants listen to one of these advertisements in one of the 2 versions. So either high versus low pitch, fast versus slow, or trombone versus flute. And then afterwards, we asked them a variety of questions, right? So we didn't just ask them about the feature that we cared about. We wanted to sort of throw them off what we were interested in here. So we asked them a majority of questions that we didn't really care about the answers. And then for each one, we had this one focal variable. So for tempo, it was how fast is the product, right? Slower than average versus faster than average. For pitch, we asked how large is the product, smaller versus larger. And then for timbre, we asked how durable is the How durable is the product? Less durable versus more durable, right? And in this first study, we found no effects on any of these three variables. So there were no differences based on the changing of the musical features, but we didn't want to give up too easily, right? So we wanted to see whether we can make a difference between these different conditions here. So in the second study, what we did was after they had heard the advertisement, so again, only one of the two versions, high versus low, fast versus slow, or trombone versus flute, before they rated the other questions, we asked them to rate the musical feature of interest. So at least they're thinking now about the music that they just heard. So we would ask them, how would you rate the pitch of the music that was used in the advertisement, high versus low? How would you rate the tempo of the music, slower versus faster? How would you rate the instrument used? Was it woodwind or was it brass, right? So getting them to think about this characteristic, but again, it was after they had already heard the advertisement, before they answered the other questions. Right? And again, still no effect of pitch, but now we did find an effect of the other two variables. So people thought they could run faster when the music was faster, and people thought that the laptop was more durable when it was a trombone compared to a flute. Right, so we wanted to do one other manipulation of attention. So this manipulation of attention was after the trial. So we wanted to do a manipulation of attention before the trial, make it super obvious that we are manipulating the musical features and see whether that would have an effect. Right, so before the advertisements played at all, they listened to both versions of just the music by itself. So without the advertisement, just listened to the two versions of the music. And then we would say, did the second music segment have a higher or lower pitch than the first, right? So now they're really thinking about pitch before they even listen to the advertisement. Was it faster or slower? Was it brass versus woodwind, right? And then they listened to the advertisement. Again, only one of the two versions, but now they know whether it's the high pitch or the low pitch version that they're listening to, or the fast versus slow, or the trombone versus the flute, right? So before they even listen to the advertisement, they're now thinking about the musical features. They're paying attention to that. And then afterwards, we still ask them again to rate high versus low pitch, fast versus slow tempo, and woodwind versus brass. And it still didn't affect pitch and size, right? So there's still no effect for the sandwich, and we still see the effects for both of the other variables. So it seems even when we call people's attention to the ad in various ways, there doesn't really seem to matter. There's no relationship between pitch and size. But we did find these other relationships when you draw people's attention to the variables of interest. Right, so we did not replicate pitch impacting size, which shouldn't be surprising given my previous dissertation work and our other failed replication attempt. It doesn't really seem that pitch and size are that related to each other, at least for English speakers. Right, but we did find effects for tempo and timbre, but again, only if you draw people's attention to the music explicitly, not if you just have them listen to the advertisement without any context or telling them to pay attention to the musical features.
Can I ask a question? Are the timbre population, did you exclude people who are trombone and flute players, or like you didn't consider their musical background?
We did not,
Okay.
consider their musical background in this particular task. Yeah, these were just MTurk participants.
Okay.
So yeah. All right, so this is another top-down influence, again, showing that specific attention to the musical features can change your perception of the advertised product. But again, this is only true if you're drawing people's attention to the music explicitly, that we can get these type of audiovisual interactions. Okay, so now I've given you a perception example, an attention example. The last example that I want to give relates to music and memory. So the question that we asked here was whether people remember more words from a list if you sing the melody, sing the list versus speak the list. Right, and this is work that I've been doing with current student Izzy Ramirez. who is about to graduate this year, but has been part of the McNair Scholars for the past 2 years. Right, so we all probably have everyday examples of learning information from songs, right? Whether it's learning your ABCs, learning the 50 Nifty United States song, that's how I remember the names of the states, or elements on a periodic table, right? But there's actually mixed empirical support for this idea of whether melodies can help learn information, at least in the short term compared to longer term settings. Especially when the information that you have to remember is more of a random list than lyrics or a particular set of things like letters or states. All right, so the background research here says that there are a number of factors that are important for whether music will actually aid memory performance. So one of these is stimulus timing. When the spoken and the sung are equal in length, so it takes the same amount of time, there was no difference found. But when the melody was slower, then it tended to have an advantage over the spoken version. Right? Also with recall timing, there's often no effect immediately after, but there is some benefit for melodies in relearning the information again later. Or benefits given some training on the melodies over time. All right, and then in terms of the outcome measure, there's less often a difference if you're doing free recall performance where you're just asking people to remember what they can from the list, but melodies can influence other measures like reading comprehension or learning words in a second language. So given this mixed support, we wanted to, in our current experiments, limit this to immediate recall, and we looked at unrelated two-syllable lists of words because most of the previous research had looked at things that are more connected, like lyrics, as opposed to just unconnected lists of words. And we looked at this with spoken versus sung formats that we presented. It took the same amount of time to do either list. And the two other features that we looked at here were music familiarity and word valence. And I'll give you an example of both of those in a minute. Right, so in this first experiment that was looking at familiarity and valence, participants heard 8 lists of 15 to 18 two-syllable words through headphones. And that list of words included an equal number of words that were positive, negative, and neutral in valence. So what I mean by that is that the positive words here are in green, things like luscious or thoughtful, right? We have neutral words like windmill or hammer, and we have negative words like afraid or betray, right? So there are an equal number of words that fit into each one of these categories, and here's an example of what it would sound like for the spoken condition.
Afraid, hammer, luscious, basket.
Right, so they're not seeing the list of words, they're just hearing the list of words and then asked their memory for it afterwards.
Afraid.
Sorry. And they were randomly assigned to either that spoken list, like you just heard, or sung to an unfamiliar melody versus a familiar melody. So for the unfamiliar melody, I used my intro sight singing book from college, and we just picked out basic melodies that are very simple and put them to this the list of words. So it would sound like this.
Afraid, hammer, luscious, basket, assault, betray, windmill, limber, honor, grateful, thoughtful, gangrene, trumpet, divorce, talent.
It's a great song. Or we put it to a variety of familiar melodies. So this one here is I've Been Working on the Railroad.
Afraid, hammer, luscious, basket, assault, betray, windmill, limber, honor, grateful, thoughtful, gangrene, trumpet, divorce, talent.
All right, and then after they listened to either the spoken or the sung version of this list, we asked them to do 2 different memory tasks afterwards. So the first one was just a free recall task. We gave them 15 boxes. They had to type in whatever words they could remember. They could do it in whatever order they wanted. And also we didn't count spelling, which made it a nightmare to try and code this because people spell things all sorts of weird ways. And we had to try and figure out whether they were actually spelling the correct word. All right, so they had 1 minute to put in as many of the 15 words as they could in free recall. And then we gave them a recognition task where some of these words they had seen before and some of them are words that had not been on that list, and they just had to click the ones that they had heard during the melody or the sung, the spoken task. All right, so I'm just going to show you the recognition results. The recall results are very similar in terms of the group differences. It's just worse performance overall on free recall compared to recognition. All right, so you can see the speech, the unfamiliar, and the familiar melody conditions here, and then the word lists, the words that were positive, neutral, and negative. And we're looking at how correct they were, so how many of them they actually recognized. All right, so you can see that the speech condition was actually the best. It was better than both of the music conditions, and the familiar melodies were actually even worse than the unfamiliar melodies. Right, so this shows that at least on the first time through, when you're first hearing these examples, it might be that dividing your attention between the music and the words is actually more challenging than just listening to the words by themselves. Right, and also we thought for the familiar melodies, it could be, right now you have to not think of the words, I've been working on the railroad, and you have to think of these other random words that I'm telling you to put in there, right? So that's even more distracting here. So in our next task, we wanted to see whether we could make the music more helpful by repeating it multiple times instead of just having them listen one time. So in this experiment, they heard the same list of words on all 6 trials. So we can see whether they get better over the course of 6 trials. And they were either randomly assigned to spoken, so they just heard the list spoken, they typed in which ones they could remember, then they heard it again, they typed it again, right? They do the same thing 6 times. Then we did it with the same melody 6 times. So I've been working on the railroad is the one we use. So they just listened to that same melody over 6 trials. Theoretically, it should get less distracting over time because now you know what the melody is, right? And so now it might be more helpful. Or we had a melody condition where it was the same words every time, but a different melody every single time. So we had Twinkle, Twinkle, Little Star, Old MacDonald Had a Farm, Yankee Doodle, Row, Row, Row Your Boat, and Jingle Bells. I'll just play Row, Row, Row Your Boat because this one's my favorite.
Afraid hammer, luscious basket, a salt betray, windmill limber, honor, grateful, thoughtful, gangrene, trumpet, divorce, talent.
All right, so each time they had the same word list, but now it's a different melody each time. That might be distracting, right? Because they have to figure out the melody and the words each time. So we're looking at the proportion recognized again by the trial numbers. So trial 1 versus trial 6 in the spoken, the repeated condition, and the different melody condition. All right, so the purple line is spoken. So on the first trial, we replicate what we found before. Spoken is better than the melodies. But you can see that with the same melody repeated over 6 trials, by trial 5, it's equal to the spoken. Right, so whereas the different melodies are still distracting. If you have a different melody every time, even though it's the same word list, it's not helpful to keep switching the melody that you hear. All right, so people remember more, do people remember more words when it's a melody versus spoken? Initially on the initial hearing, it seems like spoken is better, and familiar melodies are even worse, right? They're more distracting than unfamiliar melodies. But with repetition, the performance increases with melodies over time. And so we would predict that if we keep going more than 6 trials, there might be a point where melodies do get better than the spoken. Right? But one thing that you might notice about the difference between the familiar melodies and the unfamiliar melodies is the unfamiliar melodies were all very isochronous and they don't really jump around in pitch, right? They're just moving very simply. And so what we're doing now is looking at whether it really is the familiarity that's an issue or it's because the music is more complex in the familiar examples. And so to do this, we've created, based on our familiar versions, we've created unfamiliar versions that have the same pitch jumping and the same rhythms, but are now unfamiliar melodies. So we can look to see whether, when we're matched in complexity, whether then the familiarity still matters or whether it's more complexity. And then also what Izzy is doing for her honors thesis project this semester is she's taking those unfamiliar melodies, having the people do the task once in the lab, and then giving them the melody to listen to every day for a week. So they're gonna have to track how many times they listen to this unfamiliar melody over the course of the week, and then they're gonna come back. So we can see now it's an unfamiliar melody that we've made familiar. So now you don't have the distraction of the words of I've been working on the railroad in your head. So we can see whether now that we've made this unfamiliar melody familiar, whether that increases your performance. All right, so this again relates back to this idea that your prior knowledge, your familiarity and your repetition can actually influence your auditory memory processing in this task. Right, which together shows how perception, attention, and memory are all constructions of our prior knowledge and experience rather than following in a straightforward way based only on the auditory input itself. Right, which broadly, all of these relate back to my key research question of trying to understand auditory perception in relation to interactions across modalities and between levels of processing. So thank you very much for your attention, and I'm happy to take any questions now.
Yeah, Ben, go ahead.
In the most recent experiment that you shared, they were recalling the word lists with no auditory information, just from memory, right? Just visual word lists. Have you ever had a chance to play around with like playing some of those familiar or unfamiliar melodies while they're recalling to see if that
like without the words?
Yeah, like play it on a keyboard or humming. Yeah.
No, we haven't done that. We did another version of the familiar one because in the first study, people told us that like I spent the whole time trying to figure out what this melody was, right? And then they're like, oh, that's not what I was doing. I was supposed to be remembering the words, right? And so we played it on piano beforehand, and we're like, you're about to listen to this to the tune of "Row, Row, Row Your Boat," and that increased recognition a little bit, but it didn't really change their recall performance when they knew what song to expect. But we haven't done it when they're actually like doing the recall task.
So Ben, you're suggesting that maybe by playing the music while recall, you're giving them a cue.
The key, yeah.
It would be more about measuring retention, right? So we know that there's going to be interference effects.
Yeah.
And it seems the data supports that. However, there might be some really cool retention effects by kind of triggering those associations. Yeah, that might not be there without the auditory stimulation.
Yeah, no, it's a really good idea.
There was another question.
Yeah, I had a question about like the timbre, like how were you able to like, or what made you like pair it with like durability, for example, in terms of like when you were doing the advertisement experiment, or like what made you decide to pair, for example, like pitch, width, speed, and like et cetera?
Yeah, so we started with pitch and size, right, because that was replicating the other ones. So then for tempo, we thought, well, that has to relate to like the speed of the product, right? So that's why we chose sneakers to advertise. And then for trombone versus flute, we were just thinking about like differences between either the people who play those instruments or like the instruments themselves, like the low brass sound. People would think that that's like a more durable sound as opposed to like a flute timbre. And then we worked with someone from our marketing department to figure out like what product we should advertise. Yeah. And they helped us write advertisements that were like similar across the three products and in how they were advertising. Yeah.
Jacques.
Yeah. Is there did you look at there was an age dependence in the performance during formal training for the first experiment?
What age they had?
No, if there was an age dependent increased performance.
So, sorry, can you say that?
Yeah, so like in the first task, there was there was a formal training, right?
Yeah.
And that increased the performance of the participants.
Right.
Is there an age dependency? Like, do children
Oh.
do better?
Yeah. So these were all college students, right? So they're all the same age when they're doing the task, but they have different amounts of training, which means that they probably started it at different times, but we didn't specifically look at that. I did another task related to that with 5-year-olds, which was the only developmental study that I've ever done, and it took like 2 years, and I was like, that was enough for me. Where they were just trying to discriminate between the patterns, and we found that even 5-year-olds had trouble with these like syncopated versus unsyncopated versions, showing that already by age 5, like they haven't had that syncopation exposure in Central Virginia, right? To be able to like discriminate between those tasks. Yeah.
I'm so sorry, I've got like 6 questions. One that I'm really curious about, maybe there's also, in music, we're still battling against flutes are for boys, flutes are for girls, trombones are for boys, and I love that you had an image of somebody who presented as female who's playing trombone. I wonder if there's any, your work on metaphors is fascinating, and I'm really curious if the lower voice to make bigger sandwich could also maybe be a male-female, like a gendered thing, and if that maybe has transferred out to some of the results that you're seeing too.
Yeah, so in that example, right, it was the same voice, just pitched to be higher versus lower. So it was a male presenting voice, right, in both cases. But yeah, I would imagine that maybe it with even more of a pitch difference, right? Because sometimes if it's a larger pitch difference, then it would actually have an effect as opposed to like a small difference. But I think that would be really interesting if it is not just the pitch, but right, like the associations that we make with who is speaking or who is playing that instrument, that would have an effect, yeah.
Another thing that struck me, and thank you, this is absolutely fascinating, the ideas of metaphors around this too. There's a guy named Steve Keller who's in, private industry stuff, who's doing a bunch of, I'll send it to you, don't worry. Who's doing a bunch of really interesting stuff with perception of foods, especially if certain kinds of music can make food taste saltier. So that way people who are on restricted salt diets could actually have a better experience, or spicy. But I didn't even think about it. Both of those are metaphors for music.
Yeah.
And I'm curious if metaphors, if you've seen other metaphors that extend out into this that you might want to investigate, like there's a meme going around recently of stank face is that Sly and the Family Stone, or is that bad cheese? But the idea of funk, like, and I'm really curious if there's other metaphors out there that you might want to chase down.
Yeah, so right, so I mostly just looked at pitch, right, high versus low pitch. But in that original cross-modal research here, there have people who have looked at like other things that are more related to angular or brightness or things like that, like other auditory features that are more related to that, right? Like brightness might be more loudness, because you like turn up the loudness and you turn up the brightness. So people have looked at like some other varieties of things, but less with timbre, which I think would be really interesting, right? That's sort of like spicy versus things like that. People haven't really looked at those associations. Yeah.
We actually had a conversation in our class the other day about a study about, what was it, Booba and Kiki?
Oh yeah. Mm-hmm.
And I'm really curious if composers, because we have a couple of composers here, are suddenly rethinking too of like how to go about composing music into ways that drop into metaphor, or that they use. It seems like you're opening up a whole bunch of really interesting compositional practices that composers might be able to jump in and start using to influence their audiences without even them knowing it.
Right, yeah.
It's really cool.
Yeah. Thank you.
I'll ask one last question. In the genre experiment, I guess my takeaway is that expertise in genre is not necessarily listening to that music, but somehow producing that music.
Yeah.
And you think that production could be singing to it, dancing to it, or playing to it, or you think it's just learning how to play that music specifically on an instrument? My hypothesis is that it has something to do with this auditory and motor integration, that you learn that genre, although genres that are not as rhythmic may have been different. Do you have any thoughts?
Yeah, so we had salsa dancers, right? I went to the Charlottesville Salsa Club and learned to dance some salsa, and then I was like, okay, now you guys have to participate in my experiment, right? Like I came and danced with you, so now so we did have people who were dancers, right, who hadn't learned to play some of the instruments, and they were sort of in between, so they weren't as good as the musicians, right? So I think it is something about actually playing it yourself and that type of integration that helps you learn how the different parts, right, are related to each other. Because when you're dancing, right, you might recognize the clave pattern, but you don't have to think about how it relates to all of the other parts.
Yeah,
whereas
when
you're performing it, right, the integration of all of the parts is important.
Yeah. Well, let's thank Laura one more time. There's still more coffee and pastries upstairs.